Good morning. Happy Tuesday. Thanks for getting off to a good start in class today. By this point, I'm sure that each one of you has already read through today's objectives and key terms, as that was your first job. So here are the objectives and key terms you should have read through already. And at this point, you already should have completed today's exploratory problems with your partner. Any of the problems in the purple boxes should be done before you watch my video recap as part of step 3 on the exploratory days. Our work today is going to focus again on exploring reflections. Yesterday we learned what a reflection is. We should recognize at this point that reflections mean flipping objects over a line, which is creating a mirror image. We'll talk more about today why a reflection is considered a rigid transformation and what the word congruent has to do with all of this. As we take a look at the first set of exploratory problems today, this graph gives us point P, which is already on the graph, and we're going to work later with point R and point G. Our first job, as we take a look at some of the questions here, we were asked to label the coordinates for purple point P. And then we were also going to have to do a reflection across the y-axis. That's where point G is going to end up, and then a reflection across the x-axis for point R. So first things first, let's take a look at this graph here. How do we label the coordinates for purple point or point P? I'd always label my x first. I see how far right or left it is. It lines up with the 3 on the x-axis. So the x-coordinate for point P is 3. For the y-axis, it lines up with the value 4. It's 4 units above the origin. So the coordinates are 3 for x, 4 for y. It's 3 to the right and 4 units up. Our main job, we were asked, again, we're going to go take a quick look here. We were asked to reflect point P across the y-axis. So we're going to reflect across the y-axis. That's our big job here. And we're going to call this new thing point G. So as I take a look at the graph again, reflecting across the y-axis, the big thing to recognize, and I'm going to put a big red dotted line here. This is the y-axis. My line's not perfect. I'm sorry about that. Here's the y-axis. Runs right up and down there. This red line right there. So if that's our y-axis, we notice this is 3 units to the right. So if we're going to reflect and put point G reflected across the y-axis, it's going to be 3 units away from this reflection line, or this time 3 units to the left of it. So there's where point G goes. I'll go ahead and drag this label over here. And we should recognize for point G, which coordinate did not change? Which coordinate stays the same when we reflect across the y-axis? We don't go up or down at all, we just move sideways, so the y value is still positive 4. And instead of being 3 units to the right of the y-axis, now we're 3 units to the left, so the coordinates would be -3 and +4. For the other time, we were asked to reflect point R across the, take point P, reflect it across the x-axis, which is right here, label the new thing point R. So here we should see it's 4 units above the x-axis. If we reflect it over the x-axis, it would end up down here. And on your own, you're going to take point R and label the x and y coordinates down here. For the second set of exploratory problems today, you all were given a shape. You were asked to reflect this entire shape across the y-axis and then answer a question about what happened to some of the side lengths. If you weren't able to figure out part B on your own with your partner right now, I would hope after some help on part A, you could go do part B on your own. I'm going to take a quick run through part B. So again, we're going to label those coordinates. That's your job on your own. I'm going to skip that part here. I'm going to show you the main thing, reflecting triangle ABC, the purple one, across the y-axis. So again, we're going to be reflecting across the y-axis. So as I open and edit this drawing, here's the y-axis. Go ahead and focus on it for a second. Here is the y-axis running up and down right there. So my job, I'm actually going to go ahead. I'm going to skip putting that red dotted line here, but I encourage you to see that there. Point A, 2 units away. Point B, 2 units away. Point C is 4 units away, so it's going to flip all the way to the other side and it'll end up on the left. One thing that one student, Shania, thank you for pointing this out yesterday, realized, if we secondary click with 2 fingers onto any object in Google Drawings, they incorrectly put this under the rotate category, but they put both rotations and reflections in here. So if I want to reflect and I know a reflect is a flip, Horizontal means side to side, and I recognize this triangle is going to flip side to side. So I'm going to go ahead and say flip horizontally, and that's what this triangle is actually going to look like when we reflect. Again, we see C, the point furthest away from the y-axis 4 units out, now has to be 4 units to the left. So C flips all the way from the far right side to the far left side, and A and B, A stays on the top, B stays on the bottom, but now they're the right side of the triangle instead of the left side when we flip this purple triangle across. Definitely some new concepts. Please feel free to reach out to me, Ms. Stewart, Mr. Chu, if you have any questions about what's going on here. You're going to be on your own for part 3 for B, where you're going to be thinking about what happened to the length of AB. When we flip this triangle over, is the length of AB changing at all? And if so, how would it change? Thanks for watching to the end of the video.